Shall I
Okay.
share my screen or you want to start?
Uh, just give me a minute, sir. I'll hand it over to you. Yeah.
Sure.
So, yeah. I hope I'm audible, right, sir?
Yes, yes, you are audible.
Yeah. Thank you. So, very good morning to all. Hi, this is Venkat Prasad from Genetics, Coimbatore head office. First of all, on behalf of Genetics and Farming Technologies, I welcome you all for this Automation Studio webinar series. So Genetics is an Indian manufacturer of automation products. So we provide products like systems and solutions for various industries and also offer didactic systems for academic for technical education. We established in the year 1977 and our R&D division is approved by DSIR. We have an in-house tool room facility for tool and die machinery. So Genetics is an integrated manufacturing system certified company. So we have Pan India service facility. Genetics have 15 plus branches in India and 4 overseas offices located in USA, Germany, Africa, and Dubai. So we have 200 plus support engineers globally and 150 plus dealers and stockists. We have 1,000 plus OEMs and 17,000 plus direct customers. So Genetics is an authorized distributor of Automation Studio in India. So we have Mr. Vijay Agarhari from Famic Technology to deliver the webinar today. So we have a series of
Yeah.
webinar planned on different topics for this month. So and if you have any queries regarding, please write in the chat box and we will sure address your questions. Now I welcome Mr. Vijay to start the session.
Yes. Is my screen visible?
Yes, you are.
Okay. Yeah. So very good morning, everyone. Um, my name is Vijay Agrahari, and I'll be the presenter for today's webinar. The topics for today's webinar will be electrohydraulic circuit design, PLC control, manufacturer's catalog, illustrated library, sectional components, hydraulics virtual trainer kit, technical training material, also called as teachware, demo files, industrial hydraulics, and in the end, we will have a short question answer session. So before going through the presentation, let me quickly give you a brief about a company. Okay, so founded in the year 1986, we are more than 130 engineers and software specialists. We are an ISO certified company. We are leading the industry by designing world-class trade-oriented tools in the fields of fluid power, electrical engineering, industrial automation, and custom software development. We have our headquarters in Montreal, Canada, with branches in Mannheim, Germany, and Pune, India. We have in-house expertise under software, which includes database design, network support, multimedia applications, object-oriented web-based applications, and real-time systems. Under engineering, we have CAD CA engineers working on CAD CA systems, pneumatic systems, hydraulic systems, mathematical modeling, electrical systems, automation engineering, instrumentation, process control, and training. Under industrial automation, we have people working on PLC programming, SCADA systems, HMI, electrical controls, process simulation, system maintenance, and robotics. These are the products that FAMIC offers. Automation Studio Professional Edition, generally used by industrial clients to create, analyze, troubleshoot their multi-technology circuits. Then we have Automation Studio Educational Editions, which are used by the technical institutes and the training centers. Then we have Automation Studio Live Manifold, used for creating 3D manifold for design, quoting, and prototyping. And then we have Andon Studio, which is more related to Industry 4.0 and plant management. These are some of the objectives that we believe in. We believe in maintaining long-term relationship with our customers, provide effective user community support, uh, provide dedicated expertise, and to provide the support materials needed. These are some of the milestones in the history of MA Technologies. Founded in the year 1989, we were known as New Sim HydroSim, which was multimedia version of the software. In 1996, we switched to Windows-based platform, launching the product as Automation Studio 1.0. Since then, we had series of iterations taking inputs from clients, industries. At present, we are at in 2024, we are at Automation Studio 9.0 version. What is Automation Studio? Automation Studio provides a multi-user collaboration sharing platform that can be used for trade-oriented system design, simulation and animation, and machine documentation. We deal with different technologies like fluid power, which includes hydraulic manifold, pneumatic, some part of mechanical. Then electrical technology, which includes electrical control, electrotechnical, digital electronics. We have module for instrumentation and process control, robotics. In the field of automation, we have PLC ladder logic, CAN bus, OPC, SFC, graph set. We also have module for math module, block diagram math module. The software also provides you features like component sizing, bill of materials and reports, catalog manager, manufacturer's catalog, teachware, failure mode effects and analysis module as well. So it can help you in different aspects or different multiple programs that any colleges or institute offers, like mechatronics, industrial maintenance, electrical, robotics, automation, instrumentation and control, mechanical engineering technology, HVAC, marine technology, automotive, and etc. So the key benefits that the software can provide to students, teachers, and schools. Students can validate their theory studied in the class. They can have illustrated systems and have dynamically colorful behavior of the systems. They can reinforce their understanding of the system interaction between the different kinds of components, allowed to virtually test all types of systems. For teachers, it can facilitate the demonstration, enhance teaching and learning by working on virtual systems, easily integrates into the course, and can be handled both by teachers and students. For school, it eliminates the need for purchasing a single technology software, as it is a multi-technology software offering different technology modules, can be used in conjunction with different departments, limits the purchase of expensive and often inaccessible hardware, train students on leading edge tool commonly used in the industry. The software can be accessed remotely, and you can even provide some schedules. So if you want to have give access to students, teachers remotely, you can also have that. You can give priorities for teachers and students. You can also have time restrictions and access points, so that if you want a particular student to complete the exercise in stipulated time, you can access the schedule and define the time restrictions. The international presence, we are available in 13 different languages and sold over in more than 150 countries. Uh, the software is being used by high schools, career centers, colleges, universities, workforce development, and so on. These are the different publications available in the market for educational institutes. What Automation Studio offers is a ready to simulate environment for all the schematics present in these different books. So you can easily adapt to Automation Studio to your curriculum, simulate your own exercise to understand and enhance the understanding or before the hands-on experience. So all the circuits in different books are ready to simulate in the software, which we offer with the software. Automation Studio also provides you different interactive exercises. So we do have built-in interactive exercises that can be easily customized, and you can also create your own interactive exercises. You can also evaluate the students for the exercises designed for their understanding. You can create the digital twin of the hardware in the software for better understanding and the different components interaction. You can easily duplicate the hardware equipment virtually in the software, change the properties or create faults for troubleshooting, and use that understanding for later on working on the hardware, which will be more reliable. We do have libraries for better illustrations of the components, how it looks like in the real life, apart from the ISO symbols model that we have. So we do have illustrated libraries for different technology like PLCs, AC/DC motors, hydraulics, pneumatics. Different ways you can create schematic in Automation Studio. One could be the ISO symbols, for really important for blueprint reading of the drawings. Then you can have illustrated components used, which can give students, technicians to better visualize the product, how it looks like in the real life. And we also provide virtual trainer kit, how the connections using different types of cables like banana cables and the connections happen. You can use virtual trainer kits. This is an example of a pneumatic trainer, actual real life pneumatic trainer, and the virtual trainer kit that you can create in Automation Studio. Okay, so this is the advantage that is shown to you. When you have hardware, only limited students can have hands-on training with the equipment. But if you have hardware plus Automation Studio, different your number of students can have access to the Automation Studio, have better understanding of the circuit interaction, and then work on the hardware. So you can have hands-on training with the equipment, virtual test, troubleshoot, validate circuits prior to actual hands-on experimentation, access hundreds of components, change their properties, and see the results. Introduces students to circuit design software. They can also get introduced themselves to ISO symbols, which is important for reading blueprint circuits, and then change the properties of the components and illustrate the different scenarios. Another very important feature that Automation Studio offers are manufacturer's catalog. What a manufacturer's catalog? Manufacturer's catalog consists of pre-configured, ready to simulate components which has exact manufacturer specific data inbuilt into it. All you need to do is configure the product and drag and drop it onto the schematic. You can also find the behavior where you can test the behavior of the component before using it into the system integration. So we do provide manufacturers catalog for different OEMs like Argo Hightos, Danfoss, Eaton, um, Parker, UK, Boss Rexroth, and so on. Um, just I'll let you go through the partial list of industrial clients. So in this space, in the aerospace, we have Airbus; agriculture, we have CNHI, John Deere; energy, we have ABB, Hydro-Quebec; forest, we have John Deere, Kubota; construction, Caterpillar; Hitachi; defense, we have L&T, JCB Defense; metallurgy, we have ArcelorMittal, China Steel, US Steel; mining, Epiroc, Komatsu; offshore, we have Cameron; transport, Honda; system integrators, Harvey High-Tech, Womack; handling, Skyjack, Terex. Now, this was a brief introduction to our company. Let me quickly take you through the software interface and let's see the different topics that we have for today's webinar. If you have any questions in between, please do write it in the chat section. Our team will be able to answer that. Okay, I hope my different screen is visible to you. Yep. Okay, so at present on my screen, you're able to see the interface of Professional Edition, Educational Edition 9.0 version. At top, you have ribbon bar with different tabs into it, like Home tab, Edit tab, View tab, Simulation tab, System Analysis tab, Fluid tab, Tools tab, Student tab, Support tab, Technical Training Material tab. Under each tab, you have different features that you can use for creating your schematic. We will be looking at some of them. On left hand side of the screen, we have Library Explorer. Explorer will show you the different modules that are there in your software, like hydraulic module, proportional hydraulic, pneumatic, proportional pneumatic, drive and transmission elements, environment and control, instrumentation, process control, electrical control in different standards, JIC and IC, digital electronics, ladder logic in different standards, Allen Bradley, IC, Siemens, LS Electric, Mitsubishi, electrotechnical in different standards, IC, NEMA, electrotechnical one line, blocks, HMI and control panel. Under each module, you have components segregated as per their behavior into different categories. Like as I have expanded hydraulic module, you can see pumps and intensifiers, hydraulic actuated clutches, reservoirs, accumulators, direction control valves, fluid conditioning components, pressure valves, flow valves, and so on. When you further expand any category, you by clicking on the left hand side arrow key, you see the further categorization of the components as per their behavior, like unidirectional pumps, load sensing pumps, bidirectional variable displacement pumps, and so on. On right hand side of this screen, we have Project Explorer. Project Explorer will give you details about the project opened and the documents or diagrams included in any project, in each project. At center, we have the workspace where you create your schematic. Now, let me tell you more about the symbols and the library. Whenever you click on any module, you will find some frequently used components here. Automation Studio provides you ISO standard symbols. I can just show you this difference between them. So whenever you click on any component, you will find symbols in two different standards, ISO 2012 and ISO 1991. Um, I'll just show you the difference between the two standards. You can see the difference between the sizes of the two standard symbols. But this really becomes important when you're trying to create schematic that needs to be industrial compliant. Okay, now to show you the capabilities of the software, let me quickly create a very simple hydraulic circuit, which we will later collaborate with the electrical, PLC, and so on. Let me quickly create a basic hydraulic circuit. So all you need to do is drag and drop the component from the library. I took a pump with unidirectional pump with shaft. I'll take a reservoir. I'll take a 4x3 direction control valve. Relief valve. You can change the orientation of the valves by right clicking and changing the transformation, or you can use some shortcut keys that are available for rotating it vertically. You just press Control R. You can take for actuator, will be taking a double acting cylinder for this case. So basic components in front of us are ready. Let me zoom all the components. You can also copy the components. You just press Control and drag and drop it. So you can take multiple copies of any component on the schematic. Now, when you take your cursor to the red port, you will observe that the cursor changes into a target point. All you need to do is click on the port of the component and connect to the port of the component you want to. So I've connected reservoir to the inlet of the pump. Outlet of the pump will give flow to the direction control valve. To control the system pressure, I'll connect a relief valve at the outlet of the pump. The reservoir outlet will go back to the tank. You can also change the component position by just moving it using arrow keys. So these are rubber banding lines. It will automatically move with it. So the output from the direction control valve will go to cylinder. And the return line I've connected to the reservoir. Now to drive this pump, I'll need a external drive, which could be a electric motor or a engine. Maybe I'll take an engine and connect it to the shaft of the pump. Okay, now the very basic working circuit is ready in front of us. Without any delay, we can switch to simulation mode. So I can start normal simulation. You can see the animation happening on my screen. The pump is giving some output which is going back to the tank through relief valve, as this is a closed center position. So the flow is blocked. So when I want to extend it, I select the spool of the direction control valve, and when I want to retract it, I select the right side spool of the direction control valve, which allows the flow in this direction. Now different colors in the circuit indicates different pressure threshold in the circuit or pressure levels in the circuit. So when you increase the pressure, you can see the change in the color. Let me decrease it. You can see. So this can be user defined. If you want to define your own standards for the animation, that can be also done. So let me make it to 80 again. So you see it changed to red. You can change the parameters during simulation. Say I want to change the displacement of the pump to 50. You can change the speed of the engine and so on. You can also measure parameters during simulation. For that purpose, we have in the simulation tab itself, we have different measuring instruments. Let me show you an example of it. So we have component dynamic measuring instrument that can be used to measure the properties of any component on the schematic. So for example, I have selected the cylinder. These are the measurable properties that you can measure for the cylinder. For example, I am interested in linear position. You can define the unit of your interest and the precision level of the measured value. Similarly, you can use node dynamic measuring instrument to measure any property at the node. So you just select the node, measure the properties. So you can measure temperature, density, viscosity, and so on. Maybe I'm interested in pressure for now. Define the unit and radiate it. The third one is for differential dynamic measuring instrument, which allows you to measure differential pressure across any two ports. So I'm trying to measure differential pressure across the relief valve. Now these values can also be recorded. You just right click and say record. This dynamic measuring instrument now will dynamically record the parameters and measure it. Okay, you can see the values changing. Okay, so I've measured and recorded one iteration of extension and retraction of the cylinder. Now these recorded values can be used in different ways. If you want to graphically analyze the results, we have plotters of different variables like y of t, which allows you to measure properties with respect to time, y of x, which allows you to measure two different properties with respect to each other, and then we have a 3D plotter, which it helps you plot three different variables with respect to each other. Let me show you an example of this. So I'm trying to show you a y of t plotter. So one way of using it is directly drag and drop it the plotters into the schematic, into the, sorry, the recorded dynamic measuring instruments into the plotter, and just auto scale it. So you can see the plot of the recorded values on the screen. Let me use it again. Okay, so I'll just drag and drop it. Okay, so you can see the plot. You can add cursors to know what were the parameters at different instances. You can have multiple cursors. You can add annotations if you want to add some annotations. You can also display the legends and export the values in. So you can display the legends. So what line represents what property, you can see, and you can print it if you want to use it for documentation in some certain kind, or you can also copy this image, and you can also export these values in the form of txt files. So all the recorded values will be exported in the txt files, which you later on you can open in excel or any other file supporting software supporting txt files. Okay, now to tell you more about the properties, all these components that I dragged and dropped onto my schematic are very much configurable. All you need to do is just double click on any component, you access the properties of it. Now you can vary this property as per the requirement, and this varied property will be taken into account during simulation. So you can, even these lines are not just CAD lines, this represents actual hoses and pipes. So you can double click, see the different industrial standard lines available in the software inbuilt. So you can see the properties associated with each type of line. You can define the internal diameter length, which will later on impact the pressure drop across the lines. Every such component is configurable. Even the pumps that you see over here, you have pump parameters. You can define it. If you have efficiency curves, you just go select for the efficiency curves. Now if you select this efficiency simulation model type, you are able to enter the efficiency curves as well, which will define the behavior of the pump. Okay, I'll switch back to idle for this demonstration. Okay, now you might have also observed a question mark on either side of direction control valve. This is because this is a solenoid operated control valve, and this will require external electrical command to actuate this. Okay, so now let us try to create a very simple electrical control circuit to give the commands to these solenoids of the direction hydraulic direction control valve. For this purpose, I'll be using the electrical control module IC standard. Some of the basic components. The way of using the components is similar. All you need to do is drag and drop the required component onto the schematic. So I took a 24-volt supply or 0-volt common. Maybe I'll take a normally open push button, name it say PB1. I'll take another push button and name it say PB2. I'll take solenoid. You can name it say extend. I want to use this solenoid to extend the cylinder, so I've named it extend. I'll take another solenoid and which I'll be linking with the retract. So I want to retract the cylinder, so I'll name it as the retract solenoid. Okay. To make the connections, as take the cursor, connect to the port of the component you want to. Click on the port, connect to the port of the component you want to. Okay, so simply I'm making the connections in the electrical control circuit. Okay, now how do we connect these two different technologies with each other? So for that purpose, we have variable assignment feature in the software. All you need to do is double click on the component, select the solenoid and filter out the variable name. So I have named this solenoid as extend. So I'll filter out for extend and click on this and link it using this icon. So you can see hyperlink has been established between these two. Similarly, I can go select the right hand side, filter out for retract and click it. You can also double click and establish the variable assignment. Now let me zoom all the components and try to simulate this. I'll remove the force condition. So you can see I am controlling the hydraulic circuit using the electrical solenoid, electrical control circuit solenoid. Okay, so this is very basic electrical control circuit that we have created, and we have established their linking. But suppose you want to control the command going through the to the direction control valve solenoids through some PLC input output cards and logic. So maybe I can go for a PLC logic over here. So before that, I'll need say PLC card. So as we know that we have input output cards, go in electrical control module. You can select PLC input card and output cards. Okay, so simply I'll use this component, break this electrical control circuit and use it into the electrical input output card and build some logic. So I'll just take, you can just press shift and remove the components from the connection. I'm using this electrical control circuit here, components over here to for the PLC card logic now. So output side I'll be connecting to the solenoid. That will be okay. I'll delete this electrical control circuit. So 24-volt supply I'll connect to the input, and then the other end of the push button I'll connect it to the input address IN0. Similarly, for other push button I'll connect it to address IN1. For the output I'll need a supply, so I'll take the 24-volt supply from this and then connect this, which will be connected to address output 0. Similarly, I'll connect this in parallel to the extend solenoid, and the other end I'll connect to address out 1. Okay, so input output card I've defined. I'll connect this common to 0-volt. Okay, so input output card I have connected to the addresses. Now I can use this addresses to build the logic. Though this logic could be built in PLC in different standards. We have different libraries for different ladder logic. Standards like Allen Bradley IC, Siemens, LS Electric. I'll be using IC standard for now. You can you can just click and use the component. So I have drag and drop a rung onto my schematic where I will build a simple logic. So we have different type of components into the a library like contact, coils, timers, counters, comparator, math, advanced math, logical, file shape, trigonometry, converter, jumps, and so on. But for this, we will just see a few of them. Say I have a this normally open contact, normally close contact, say coil. I'll be using this to create some logic. So you can simply add it into the rung. You can create a rung. Okay, so I'll just connect it to the first rung. Okay, now this should get uh, input when IN0 is pressed. So PB1 is pressed, which will energize IN0, and this should give output to output 0. So I'll connect this, double click, filter out IN0 variable, connect to this, and then output 0 I'll connect to output 0. I'll filter out for output 0. I'll start this simulation. You can see it is taking input from the ladder logic, but when I press it, it's just extending. But when I uh, press, hold, and remove the control onto the push button, it de-energizes. So maybe I need to latch this. So I'll be latching it with the output control. I'll take another contact and latch it over here with output 0. So now let us try to simulate it. So you see when I just single press it, the cylinder extends. So right now the ladder also only includes the extending part. To include the retraction part, we can just add another rung for retraction. And now retraction should happen when IN1 is getting energized. So I'll just link it with IN1 output to IN1 because retract is connected to output 1. So I'll just go here and check for output 1, and then this will be latched with output 1. Okay, now to break this, because both the solenoids should not get the signal at the same time, so will be using a contact breaker over here. So here, so this the first rung contact should be braked when IN1 is getting energized, so that only one of the rung is getting input. So IN1, I'll just filter out IN1. Similarly, second one, I'll filter out for IN0. Zoom all the components. Now let us try to simulate this. So you can see this cylinder is extending based on the logic that I've built using PLC. Okay. So this was a very basic simple logic that we have created. If you want to add some sensor switches, you can also add them and maybe kind of say automate the circuit. You can also do that. So maybe I'll give you a simple scenario where I have a sensor for in the module. I took a sensor for proximity sensors. I place it for sensing the say completed retracted position of the cylinder, and another sensor for sensing the extended position of the sensor. So I'm just naming it A1 and A2, the two proximity sensors. Then for the electrical circuit, to get sense these sensor inputs, I'll use sensor switches. So maybe I'll go here and go for sensor switches. Proximity open, normally open sensor switches. I'll take two sensor switches. So this switch will be turned on when A1 position is reached. So pressure sensor A1 is active. So this will be linked to A1, and then I will link the other one to A2. Instead of this push button, I'll replace it with sensor switches. Okay, now you will be able to see that I've automated the complete extension and retraction sequence of the cylinder using PLC logic, sensors, and sensor switches. So this way you can create different scenarios in Automation Studio and build some logic. Okay. Now, one of the feature that I told you about our manufacturer's catalog, these are generic components that we drag and drop it from the library. But if you want to go and use manufacturer specific component, so there are different OEMs providing different components as per the part number. They have specific behavior inbuilt into it. So you can also have access to this. One way of accessing is through online catalog. So in the home tab, you have online catalog. Once you click on it, it will open online catalog, which will look something like this. So you can click on any manufacturer based on the requirement and access the category. So you can see I can click on the component of my interest. I can configure the part number, properties, documents, and how it looks like in the real life. There are images associated to it. So this is online catalog. If you want to also download it and keep it in your local system, you can also have access to the online catalog through catalog manager. All you need to do is browse the path and open the file. Okay, so I have already opened a Sun Hydraulic catalog on my catalog manager. So this is Sun Hydraulics catalog. You can see this is the cartridge valves catalog. Categories as per their behavior: pressure control valves, flow valves, direction control valves, and so on. Maybe I'll show you one example how it really looks like. So maybe I'm operating a solenoid operated direction control valve. This is generic one, but I want a manufacturer specific with exact behavior. So this is DNDC Sun hydraulic valve. You can configure it as per the need or of the system and the requirement. Different combinations, you can select it from the list down, and once you have configured it, you have the part number over here. All you need to do is drag and drop it onto your schematic and use it. So in the data tab, you will find the information related to the data of the component, images, documentations, nodes, 3D, and so on. So I'll just you can use this, and every such test bench will have, every such manufacturer specific product will have a test bench associated to it. You can click on the um, I'll not open because in automation, in educational edition you can open just one file at a time. So I'll just, this is where you can find the test bench. So it's opening right now. Okay, so you can see the test bench or the behavior associated to it. You can simply follow the instruction. You can test the behavior of the component by say I want to change the position. I've changed the position. You can change vary the flow and see the cursors following the curve. So this is based on the exact manufacturer specific data, the behavior that you see on my screen. So this is manufacturer specific component. We also talked about, let me close this test bench to show you more features of the software. For this webinar, I'll open a new project. Okay, so we saw some ISO symbol circuit that we have created before, but Automation Studio also provides you the illustrated library, components library, which you can access is by this icon. So we have different illustrated libraries. For today's session, we will be looking into the hydraulic illustrated components. So all you need to do is select the library and open it. So this will be opening an illustrated library, which will give you a feel of a real life component look. So all you need to do is the same way, drag and drop the component from the library and select the component from the library and drag and drop it. So I took up a unidirectional pump. Maybe I'll try to create the same circuit, but using the illustrated library. Now I'll take an electric motor, I connect it to the shaft of the pump. I'll take a reservoir, I'll just add it over here. I'll take a relief valve. I'll take a direction control valve. So yeah, this should work. Maybe I'll take a cylinder, selecting cylinder. So as we created using ISO symbols, you can also use illustrated library to create illustrated library components circuit, which will give you a better feel of how it works or how it really looks like in the real life scenario. I'll just make the connections quickly. So I made the connections. Now I can just simulate it. So you can see I can even simulate the illustrated library using the controls over here. So I'm using this lever. Similarly, we have illustrated library for cross-sectional. You can access the cross-sectional library from here. Click on it. I'll try to create the same basic circuit again quickly. So I'll take a relief valve. I'll reservoir tank. This is to show you how different ways you can create the same circuit using different libraries that we have in the software. Maybe in this case, I'll be using a proportional uh, direction control valve. Maybe for actuator, I can use, instead of cylinder, I'll be using say motor in this case. So I'll just add a motor over here. So simply you can just make the connections quickly. So this port will be P port, A port, T port, and B port. Relief valve for controlling the pump outlet pressure. So I'll just connect it over here. If you have any questions, please do write it in the question section. We'll be trying to address them at the end. So simple hydraulic circuit created. I can give the lever input. You can see the motor rotating in one direction, input from this side and output from this side. When I take it to the other side, input from this side and output from this side. So you can have different virtual systems or cross-sectional systems using different illustrated library components created in the software, which can give a better representation of the behavior of the component. You can also use the ISO symbols, which will be helping students for blueprint reading of the schematic. Okay, now let us switch to the other topic we had for today, which is virtual trainer kit. Let me now take you simply to a virtual trainer kit, just an example of it. Okay, so this is kind of a virtual trainer kit created using illustrator libraries and some trainer kit scenarios that we have. This really helps students to analyze and see how the connections really work in real life and how they are made using cables, wire hoses, some maybe banana cables in case of electrical connections and so on. So our student can have access to different ports, select the port and connect to the say this push button from the electrical control circuit. You can change the color of the line using the controls. You can see this banana cable is now connected over here. Maybe I want to add this solenoid in series with this banana cable. I can connect it over here, and maybe this connection is not proper right now, so this I have connected over here. You can change its position using these handling tools. You can change it over here like this, and this output I'll be connecting back to the other end. So this is I've connected in series. Similarly, I can have this online connected to the second push button in series. So this will be connected over here. This maybe take input from here. So I'm just adding this solenoid of the direction control valve in series with the push button so that the electrical control circuit or the kit will be controlling the energization of the solenoids in the direction control valve. So just try to simulate it. So you can see I'm controlling the motion of the cylinders or the actuation of the solenoids using the push buttons over here. So students can really have a hands-on experience on this virtual trainer kit before actually working on the hardware kit. A better understanding of the component interaction will be there before working on the actual hardware kits. Now let me give you a brief introduction about the teachware or the technical training module that we have in the software. In the technical training material tab, we have different technologies teachware. You can just click on any technology. It will open the teachware for it in the form of catalogs. So here student can have a better understanding of the different principles or the different concepts in the technology, like they can have access to the Pascal principle, answers of questions. They can have an understanding of the flow principles, loss of pressure losses in the orifices, pressure compensation. If they want to know more about the component and different types of components, their behaviors, and how they really work in the real life scenario. So we have teachware for different technologies. Right now I'm showing you the hydraulics one. So different types of pumps, different types of components. This teachware is interactive and it has a voice inbuilt inside it, which you can just open the file, play it, and it will have a voice which will give you or instruct you the basic steps that you need to follow. You can also evaluate using the exercises which are there. So he can simulate the circuit, have some understanding, and then using that simulation understanding, they can answer the questions, which they can later save in the form of PDF file, and which can be used for evaluation later on. So we do have such different teachware scenarios. So this is what you can use, and this is easily customizable. You can even customize it for your own requirement. In addition to this, as I talked to you about the different circuits in the different books that are available in the in the market on different technologies. So I have opened the books over here. This will contain all the all the circuits that are there in the book, which are ready to simulate. You just need to click on the schematic and just open the file. This will allow students to have understanding of the actual working of the circuit, which are available in the books in the market. Okay, so we do have different books, and the circuit in different books are available for simulation readily with the students and teachers. So this can help for the students for understanding and for the teachers for better demonstration of the concepts. So all you need to do is open this PRX file and simulate it. Okay. Now let me take you through few examples, through few demo files that we have in the software, so that you get better idea of how the working, its behavior, what can be done through the software. Let me start with one of the file that we have. Um, Let me open a file. Okay, so this is one example of illustrated PLC hardware. This is a Siemens PLC, and this is how it really looks like in real life, and with the input ends and the output card ends. These are having some inputs proximity sensors, as we saw in the example in the demonstration or the webinar before. And at the outputs, we have some solenoids which are getting energized based on the outputs addresses. Here we have the ladder logic for the sequence that we want for this particular operation. Imagine it as a rod bending or a plate bending operation. So I'll start the simulation. You can observe the operation happening, the clamping, the bending, the second bending section, and then retracting of the cylinders. So this sequencing that you can see is happening based on the PLC logic that you have. I've reloaded it and you can observe the sequence again. Okay, so one example of the real life application or the industrial application of the rod bending or plate bending using PLC input output cards and ladder logic. Let me show you some different examples as well. Saurabh, if you can just come up with the questions, we are just approaching the end. Let me also show you the virtual system for the pneumatic one. You can see. Okay, so this was virtual system for pneumatic. Maybe I'll show you an industrial application where you can see a press machine, a baler press machine. Okay, so here you on the right hand side of the screen, here we have a 3D model which is linked to the hydraulic cylinders that we have in the schematic, hydraulic schematic. The sequence that is happening for this baler press application, you can observe it in the 3D as well. We have some HMI over here to indicate the operation process happening, and this all is interlinked to each other, and the influence or the animation that you see in the 3D is through the hydraulic circuit. This hydraulic circuit also uses the manufacturer specific component from our catalog, so the behavior is also as per the manufacturer specification. Individual components are manufacturer specific. Yeah. One more example maybe I can show you. Maybe I'll show you from mobile hydraulics. Simplified excavator. So this is an industrial application of say mobile hydraulics. So here the hydraulics that you see is for the excavator, different motions involved in excavator like boom, arm, bucket, swing drive, and the loading or the joint constraints are defined using the mechanism in the software. See, again, this all different features are interlinked to each other. So the motion that you or animation that you see is based on the cylinder motion in the hydraulic circuit. Okay. Yes, Saurabh, we can open for the question answer session.
Yeah, so if anybody has any question, you can just put the questions in the question pane. So I can see some questions like, can we create a runtime file like lab view from this software? So
Maybe I'll need to look at the question. Okay, we create a runtime file like LabVIEW for the software. Maybe I'm not very much aware of how LabVIEW works, but maybe if we can unmute him and if he can better uh, tell us more detail about this.
runtime file, I guess he is asking for simulation file. So if it is asking for simulation file, that yeah, we can save it in the .prx format, right? So is it
Uh,
like
yes, we can save the file in different formats, like the file that you created. Once you save it, it will be saved into a .prx format. So once you just right click and save it as, it will save the file in the .prx format. Also, if you want to save the animation or the working of this simulation into some say um, video format or something, you can also do that. So we have this recording section, so using these options, you once you simulate it, the simulation can also be recorded and saved into video format. Also, we can export the file in different formats over here like PDF, DXF, and SFC, GraphSet, and so on.
Yes. So next question is like auto naming of hydraulic or pneumatic components is available. Auto naming of
Uh,
hydraulic and pneumatic components.
Auto naming of hydraulic component. If I understand the question well, maybe. So you mean to say if I have the generic component, whether I can name it as per the
Yeah.
manufacturer specification or something? So yes, that is also possible. You can just go access the data properties here in the when you scroll down. You can add different information into this. So if you want to add, say this is Parker cylinder, say some description you want to add, you can add it, and this will be later on seen. You can also make it visible using these checkboxes. So even that can be done. Yes, possible.
Yeah. So next question is how to create the 3D model.
Yes. So we have another feature that we in the software that we did not look into for because not intended for today's topic, but I can show you how you can create a 3D module quickly. We do have a 3D module, 3D diagram that you can simply add. You right click and add the 3D diagram. Once you add the 3D diagram, this will show you features related to 3D interface. Okay, so you can create your 3D drawing, or you can simply import the part maybe created in some other software. If you have the file in STL or .stp or IGS format, you can simply import the file from other software and use it in Automation Studio. So this is how you can work on 3D. You just need to access the 3D diagram and use the tools from 3D module.
Yeah. So for other questions, like I am not able to see any specific question, so we will contact you for other questions. Okay, and you will get the recording link by tomorrow. Okay, recording link and the certificate. Right. So please do register for the webinar. Okay. So Venkat, you want to say anything before ending the session? Yeah, Venkat Prasad,
Uh,
are you there?
yes. Okay. Yeah. So
Yeah, yeah.
related to SCADA, I see you have already answered. So
Hmm.
we have different webinars lined up, and this was the very first webinar in this session. We have different webinars in the future that we will be taking, that will be happening. We invite you to join the webinars as well, so you can have a look at the different webinars um, for the future.
Okay. Yeah.
Okay,
Okay then.
so
So
so that's all from our side. If you have anything, any questions, any particular requirement about any component, any circuit behavior, or any questions of any kind, please do get in touch with us. So we will be more than happy to help you.
yeah. So thank you very much for attending today's webinar. Okay. Thank you. Have a good day.
Thank you. Have a good day.
Thank you all.
Thank you
Thank you
for your
for attending the
participation.
webinar. Thank you, Saurabh sir and farming team. Thank you.